atom is the smallest unit of matter that has the properties of an element. Atoms are made up of three different components called subatomic particles, which are protons, positively charged and found in the nucleus, the dense center of an atom, neutrons, neutrally charged and also found in the nucleus, and electrons, negatively charged and found in the electron cloud. Democritus lived approximately from 460 BC to 370 BC and was thought to be the first atomic theorist. He believed atoms were small, solid, and indivisible particles that could differ in shapes and sizes, and were also in constant motion and would collide with one another. John Dalton incorporated Democritus's ideas and also claimed that atoms cannot be created nor divided. Two or more different atoms can combine to form a compound. Any combination, separation, and rearrangements of atoms is a chemical reaction. Joseph John Thomson discovered electrons from his cathode ray experiment. To do this, he placed a magnetic field around the tube and shot an electric current through it. He noted that the current bent in the direction of the positive part of the magnet and concluded that the current was negative. He proposed the plum pudding model. This model consisted of a positively charged sphere with electrons spread throughout. Isaac Newton suggested that atoms are held together with attractions, otherwise known as forces, and stated matter is formed of solid, massy, impenetrable particles. Mendeleev arranged elements into 7 groups by similar properties and developed the periodic law, which is the properties of elements or periodic functions of their atomic weights. G.J. Stoney proposed that electricity was made of negative particles he called electrons and also estimated the charge carried by a single hydrogen atom. Marie Curie studied uranium and thorium and called their spontaneous decay process radioactivity. She and her husband Pierre also discovered the elements polonium and radium. Frederick Soddy observed the spontaneous disintegration of radioactive elements into variants he called isotopes. He discovered half-life, which is the amount of time required for something to be at half of its original content. He also made initial calculations on the energy released during decay. Nagaoka developed the Saturnian model based on Saturn's rings. He proposed the valence bond theory, which began to explain how atoms bond with each other, which led the way to understanding the principle of ionic bonding. Richard Abegg concluded that noble gases were stable because there were 8 electrons in the outermost shell. He believed that if that were true, that maybe the electrons of other elements exchanged electrons to create a stable molecule. In 1938, Glenn Seaborg was involved in identifying 9 transuranium elements, which were elements 94 through 102. This led to an extension of the periodic table. All of the elements before these new ones existed on Earth naturally. The new elements he created were the first elements to be man-made in a laboratory.
In 1911, Ernest Rutherford performed the gold foil experiment. Rutherford thought that if Thomson's plum pudding model was correct, then the mass of an atom must be spread throughout. He tested this by shooting alpha particles at a high velocity into a thin piece of gold. He believed that there would be nothing blocking the particles from passing through the atom. He noticed that many of the alpha particles went straight through the gold foil, but some actually bounced in different directions. Rutherford was able to come to the conclusion that Thomson's plum pudding model was incorrect, and most of an atom's mass is concentrated in the center, or the nucleus. In 1914, physicist H.G.J. Moseley used X-ray tubes to determine the charges on the nuclei of some atoms. He also determined that the atomic number of an element is equal to the number of protons. This reorganized the periodic table, which arranged atoms based on atomic number instead of atomic mass. In 1915, Niels Bohr created an atomic theory that electrons orbit the nucleus at set distances. He thought that electrons can move between different levels and only a set number of electrons can be at each level. When the atom gains energy, the electron can jump to a higher energy level. Likewise, when the atom loses energy, the electrons will return to ground state, which is the most stable state of that electron. This model worked well for small atoms like hydrogen, but not for bigger, more complex atoms. The next physicist, Francis Aston, discovered the existence of isotopes in 1919. He did this through the use of a mass spectrograph, which is an instrument which can measure the masses and concentrations of atoms using a magnetic force on a charged particle. In 1923, Louis de Broglie came up with the theory of wave-particle duality, which means that electrons can act as particles and waves, just like light. He also said that waves produced by electrons set up a standing wave of certain energy, frequency, and wavelength. In 1929, John Cockcroft and Ernest Walton built a linear accelerator that shot protons out at very high speeds. With this machine, they were able to become the first physicists to split an atom's nucleus. This research helped in the development of nuclear power. Next, in 1930, Erwin Schrödinger came up with the theory of wave mechanics. He created the equation that is shown here. It is able to predict the probability of finding a particle at a certain position. He came up with this equation with the fact that atomic particles were wave-like in nature. Also in 1930, an important physicist, Paul Dirac, made discoveries of antimatter. He created an equation that explains how things very small and very fast, in this case electrons moving near the speed of light, behave. He didn't realize until he looked at this again that he also predicted that each particle has a mirror image antiparticle that has identical properties, except for an opposite charge. Protons have antiprotons and electrons have positrons. These can join together to form antiatoms and antimatter. Then, in 1932, James Chadwick discovered the neutron in an experiment that he made. He noticed that when positively charged particles were shot at beryllium, a beam was formed. This beam wasn't affected by magnetic or electric fields. Chadwick was able to conclude that a neutral particle existed, which he called the neutron. He was also able to determine that this particle was slightly larger than the proton.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there. The scientists concluded that atoms must be mostly empty space, and that because some particles are deflected, there must be a small positively charged central mass, which they called the nucleus.